Welcome back to Program Logic and Design. In this section, we're going to be discussing our pseudocode statements and our flowcharts. Alright, so what we're going to be chatting about is pseudocode. Now, what is pseudocode? Pseudocode is an English-like representation of the logical steps it takes to solve a problem. So if we have a look at our making a cup of tea here, we organize everything together. We plug in the kettle, we put the tea bag in the cup, we put the water into the kettle, we wait for the kettle to boil, we add water to the cup, we remove the tea bag with a teaspoon or a fork, we add milk or sugar, depending on our preferences, and then we serve. It is in a logical order, and we haven't eliminated some of the important steps like boiling the kettle. Alright, next we have our flowcharts. Flowchart is a pictorial representation of the logical steps it takes to solve a problem. If we have a look at our problem here, it is pictorial. I'll discuss all the different shapes for you and what they mean later. But just what you need to know is that you go, lamp doesn't work. Okay, lamp doesn't work. Is it plugged in? If it's not plugged in, then we plug it in. If it is plugged in, then we're going to check the bulb. Is the bulb burnt out? Yes, it is. We replace the bulb. If it's not, then we repair the lamp. Then something's definitely wrong with the lamp. Now, I'd like you to think of pseudocode and flowcharts as of a map. When you give a friend directions to your house, the friend will either write down the directions. You turn left at this road, you turn right at this road, and on your right-hand side will be my house with the number 2 or 3 or whatever it is. Or you will draw the map, literally draw it. You will draw the road, you will draw this road intersects this road, and this road's called this road, and then you probably draw a flow line on how to get to your house on the roads which you have drawn. So that's basically what pseudocode and flowcharts is. It depends on what your client prefers. Most clients prefer flowcharts because it's more pictorial, it's more an understanding for them is pictures. Alright, let's discuss how we actually write pseudocode. Pseudocode representation of our number doubling problem. What we have is we've got start, we input our my number, we set my answer equal to my number times 2, we output my answer, we stop. We've already discussed it, but what I want to show you is the standards of writing pseudocode. Your programs begin with start and end with stop. These two words are always aligned. If you have a look, start and stop. Remember, you can also use begin or end. It's your preference, as long as it's understandable and they are aligned. Next is each program statement performs one action. For example, input, processing, output. Alright, so input my number, we process my answer using my number multiplied by 2, and we output my answer. See how they are all directly aligned underneath each other. Program statements are indented a few spaces more than the start or the module name. Alright, we'll discuss modules later, but you can see a few spaces is indented from that. As you can see, I've actually left out the second and the third one. We'll discuss that when we do modularization, which is much later. Now, each program statement appears on a single line, if possible. When this is not possible, continuation lines are indented. So we will have they're on a new line, and if this was a long processing, you will just indent a few spaces and then carry on writing. Okay, you'll see this later when we do when we write bigger programs. Program statements begin with lowercase letters. This is why I like you guys using Notepad++, because you won't have a problem of auto capitalization, which Microsoft Word does for you. You can always right click on, I'll show you later, right click on a drop-down menu to make sure that it doesn't have the auto capitalization, but I'll show you that later. All you need to know now is just please make sure that everything is lowercase. And last but not least is no punctuation is used to end statements. So there's no full stop after stop or end. Which brings us to drawing flowcharts. Now, these are our flow lines. They connect shapes with arrows. You draw geometric shapes that contain the individual statements. That's how you create a flowchart. If you have a look at my input symbol is a parallelogram. I don't know if you remember what the shape is called from maths, but this is a parallelogram. It indicates an input operation. And my processing symbol contains processing statements such as arithmetic, like my answer equals set my number multiplied by 2, and it is a rectangle. My output symbol is the same as my input symbol. It is a parallelogram, and it represents our output statements. Our flow lines, which is the arrows, it's a line with an arrow, shows our direction, and this connects our steps. Our terminal symbols is start, stop, begin, end. They are our terminal symbols. We terminate our pseudocode or our program with a start, and we terminate it with a stop. Start and stop symbols, they're shaped like a racetrack, and we also call them a lozenge. So a lozenge is like a tablet, so a lozenge is more fancy word for a tablet. Drawing flowcharts, our continuation is, here's an example of our doubling a number program, which we've did previously. We have our lozenge, which is our start. It's our terminal statement, start to stop. Then you have your flow lines, which says, okay, from start, you flow towards my parallelogram, which is my input, my number, which is our input. Then we process. So my flow line goes towards my processing here, which is my answer. We're processing what my answer is going to be, which is my number, whatever we input it in, multiplied by 2. Then we flow towards our output answer, output my answer, and that's also parallelogram. For pseudocode, we will just go start, input my number, set my number, my answer to equal to my number multiplied by 2, output my answer, stop. Indented, indented, new line, new line, new line, new line, new line, lowercase, 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 lowercase. Now, I would like you to think, all right, which is the better tool for learning programming? Is it flowcharts or is it pseudocode? There's a very interesting article which I have given you on the structured flowline niche. What they actually did is they took a couple of students and they said to them, which do you prefer? Do you prefer structured flowcharts, which is a complex algorithms using a graphic method, or do you prefer verbal method like pseudocode, like writing English in like an English-like manner? And what was interesting is that 75 to 89% of the students actually preferred flowcharts. And then they went on to say, okay, how strongly do they actually feel about flowcharts? Please have a read through this article. It's just a little bit of just the abstract version of it. It's quite interesting to see what people actually think about flowcharts. Some of you might actually think that pseudocode is better or flowcharts is better, but it is a personal preference in the long run. To be honest, I preferably prefer pseudocode because it's like programming. But for my clients, they prefer flowcharts because it's more graphical and they understand it a lot better than what me writing like a code like English language pseudocode. Repeating instructions. Alright, now program in figure 1.6. Here's 1.6. The flowchart and pseudocode for the doubling of number. This only works for one number. It's not feasible to run the program over and over 10,000 times. It's not feasible to add 10,000 lines of code to a program either. So what we actually do is we create a loop, which is a repetition of a series of steps instead. And when you create a loop, you've got to avoid having an infinite loop. And an infinite loop is basically when your flow of logic never ends. It just goes on and on and on and on and on. Right, if you have a look at figure 1.7, this is insufficient code. You'll see that there's like a little bubble here. There's you would never want to write such a repetitious list of instructions. So we input my number, we set my answer, we create a new number, and we create a new answer, we output that answer. We create a new number, output answer. Imagine doing this 9,997 more times. It's repetitious of code which is not needed. What would be easier is to create a loop. If you have a look at the flow line, at my answer we go up, go back to that flow line just before the input my number, and then we start that process again. We loop it again, process. Now, this is also a flaw, because what happens is that it's going to keep going over and over without ending. Now, how are you going to make this end? Which brings me to your next video, which is using a sentinel value to end a program.